Assalamualaikum. My name is Amir Aiman bin Ahmad Zani. So today I will present the introduction and objective of back system. So as we know, back friction is term which to use to describe the frictional force between a bed and a surface, and it will be the frictional force and with the surface of the pulley. There are two types of bed which are flat bed and wheel bed. And back friction is an important aspect of mechanical engineering, particularly in the field of power transmission system. It enables the efficient transfer of power and play a crucial role in the design and analysis of power transmission system. So back friction refers to the frictional force that exists between a bed and the pulley it webbed out. When a bed in contact with a pulley, frictional force are generated due to the tension in a bed and the normal force between the bed and the pulley surface. This frictional force enables the transfer of power from the driving pulley to the driven pulley. Okay, so for the objective, we already list three objectives. So the first one is to understand tension acting on the bed or rope calculated by the bed friction equation can be compared to the maximum tension the bed can support, which means the bed friction is used to determine the tension acting on a bed or rope that is wrapped around a pulley or a wheel. This equation takes into account factors such as coefficient of friction between the bed and the pulley, the angle of wrap, how much the bed wraps around the pulley, and other relevant parameters. And the second one is to understand effect of friction in different type of bed, which means the effect of friction in different type of bed is a critical consideration in mechanical system, which is influencing power transmission and efficiency and reliability. Understanding the frictional characteristic of bed type is essential for selecting the most suitable option for a given application and ensuring optimal performance. Okay, for the last one is to understand the effect of angle of lap around the pulley or torque transmission, which means the angle of lap refer to the angle subtended by the arc of contact between the bed or rope and the pulley surface. It represents how much the bed wraps around the circumference of the pulley. The greater the angle of lap, the more contact area that is between the bed and the pulley, which affect torque transmission.
My name is Malaysia Pika binti Hussein, so I will explain about the methodology of this case. So we have to separate in two experiments, and I will explain about these two experiments. So in these two experiments, we have effect of the different angle of the contact and different bed material. But in these two experiments, both are use a set initial F1 is 15N. So the first experiment that we have a different angle of contact. So we have a 60 degree, 60, 19, 120, 115, and 118. So in this experiment, we have placed the hem rope was placed to the plate groove using the home rope. So the next is we have an initial tension of F1 where is 15N was set by adjusting the pulling 1 and trick step 9. Okay, so the next is the pulley was turned counterclockwise with constant speed, and the reading of F1 and F2 were noted down. So I will continue to the next experiment, where is experiment 2. We have used a different bed material. So with different type of material, whereas we have a leather, hams, and rubber. The round belt ham was placed to the flat groove, and the edge of the contact was set to 118, and initial tension of the F1, as I mentioned before, is a same both of the first experiment was where is 15N. So the pulley was turned counterclockwise, and the reading of F1 and F2 was not done, same as the experiment 1, and the round belt ham was changed to another type of belt. So by turning the pulley, the reading F1 and F2 for each type of belt was not down. So I think that's all from me.
Okay, my name is Xiao Xuebin, and now I would like to present my part, which is result and discussion. And now we see this. This is the result from experiment 1. The figure show is the chart of F1 over F2 and COF vs angle. And in this chart, we can see that the ratio of F1 over F2 increase with the angle of contact. When the angle become larger, the F1 over F2 increase. And neither that we can see that the COF decrease when the angle of the contact increase. Now we move to the experiment 2. Experiment 2 that we use the different material for our experiment. The first material is leather, second is hemp and rubber. And in this result, we can know that uh, get the result of COF. The leather is the champion, and the rubber is uh, and second one, and the third one is hemp. Okay, I will pass to my next member.
Assalamualaikum warahmatullahi wabarakatuh. My name is Danish Daniel bin Abdul Hisham, and I will be explain about the solution of the slippage belt. First and foremost, a study was conducted in which a sensor was positioned to monitor the outer rim of each pulley and detect the transmission of reference point. Upon detection, each signal is formatted and applied to separate the inputs of the microcontroller using a software algorithm that determines the speed of the drive and the load in relation to the microcontroller cyclic program speed. Furthermore, the the difference in radial speed of the drive and loads is accountable to belt slippage, which the result indicate that the developed V-belt monitoring system is very accurate at measuring uh, this issue. The system can accurately determine the running state of transmission system and present this with belt slip data locally and remotely. Lastly, this system is robust, repeatable, and capable of logging the difference in radial speed of the drive and the load over a long time period. Therefore, it is capable of indicating when belt slippage becomes excessive. Thus, it can present to some degree of the need for maintenance action on the system.
My name is Muhammad Alif bin Muhammad Faudin, and I'm going to explain about the conclusion. In in conclusion, the rubber belt has the highest coefficient of friction, making them suitable for application requiring strong grip and high frictional force. The second is hemp's belt provide good friction, but may be less consistent due to the natural variability in the material. And the lateral belt offer moderate friction and a balance of performance and durability. In the end, we can use this application into finding into because the finding of this experiment can guide the industry towards the selection of belt material for different industrial application, where the choice of belt impacts the efficiency, durability, and performance of machinery. That's all from us. Thank you.